In our next lesson, we are going to be looking at trigonometry. Now, for trigonometry, as what we are doing at this level is we're looking at right angled triangles specifically. Now, when I have that triangle and I've got an angle that's given to me, so I've got my theta over there, I can name my sides of my triangle from that theta. So opposite, there is exactly opposite the angle that we've been given or we are looking for. The adjacent is exactly where we are looking next to it, and my hypotenuse is opposite to my right angle. So that's, the hypotenuse is the same as in Pythagoras, but opposite and adjacent, you need an angle in there to be able to name them. So you need to know how to name those three sides. All right angled triangles of a specific angle are similar triangles. In other words, it's almost like you've just made enlargements. So if theta is 30 degrees, all right angled triangles with a 30 degrees would be similar triangles, and that makes the sides have common ratios. These ratios are called sine, cosine, and tangent. And sine theta is the opposite side divided by the hypotenuse. Cos of theta is the adjacent side divided by the hypotenuse, and tan of theta is the opposite side divided by the adjacent side. You need to know those ratios. How to use SOHCAHTOA. Now, when I was at school, I used to learn some old hens cackle and howl till old age, and that was how I remembered those letters. You may just want to remember SOHCAHTOA, and that is up to you. So first of all, I like to write them out in triangles. Now, you use these triangles in science, and you can use them in this as well. So if you write out the triangles as shown on the left, decide what ratio you need, label your triangle and see what you have and what you want to find as in your right angled triangle. If something is next to each other, you are going to multiply them. If they are above each other, so say you're trying to find that hypotenuse, you would divide the opposite with the sine of the angle. So please could you copy those down, and I will show you how to use them in some examples coming up. There you go. So solving. In this triangle, this is my angle that I have over there, so this is theta. Then V that I'm trying to find is my opposite, good, and the 30 is my adjacent. So on my SOHCAHTOA, and I'm just going to write, I expect to see you writing, sorry, it's very SOHCAHTOA. Some old hens cackle and howl till old age. Now, I've written them as these triangles like this, and I will show you why in a minute. You may have done this and you're thinking, oh, I know how to do this. Then could you just do it? Okay, so in this case, I've got my adjacent side and I'm trying to find my opposite side. Which of these three uses A and O? Looks like TOA. So I'm going to do my TOA triangle here. Now my opposite is V, and T is tan of the angle. So I'm going to put in tan 34, and in that little bit there is my adjacent, that is 30. Now I'm looking for V. V is my unknown. So V equals, these are next to each other. When they're next to each other, I multiply, so it'll be 30 times tan of 34. It's always tan or sine or cos of the angle. I just like to do it this way so that I don't have two numbers next to each other. So 30 times tan of 34. You can put that into your calculator just by 30 times tan 34. And you will get the answer 20.2. Oh, both my answers came up, so let's work towards this one. So looking at my example 2, there's my angle. I've got my opposite and my adjacent again. This time, however, I'm looking for my adjacent and I've been given my opposite. So I'm going to do my triangle, probably a bit bigger this time. So it's O and A. So again, I'm looking at O and A there. So O is 8. It's tan of 31. And A is V. So that's what I'm looking for. Okay, so in this case, it'll be V equals 8 divided by, or you can just put it over, tan of 31. So in your calculator, you're just going to put in 8 divided by tan 31. And what do you get? 13.3. Okay, so using the triangles can be a very effective way of working out what your answer is. You just need to remember, if it's above, it's dividing whatever's above by the tan, and if it's next to it, you are multiplying. Let's look at another example. I'd like you to do these two, please, and then I will go over both of them. I'm not going to push the answer until I've done the setting out, just so that you can work that out. So please push pause now, label them, and write the answer. Okay, so that's my angle. This is my opposite. This is my hypotenuse. What uses O and H? Hopefully you've written SOHCAHTOA down somewhere. O and H is sine, so it's going to be SOH, big triangle underneath. So the O in this case is C, the H is 15, and it's going to be sine of 50. So C equals 15 times sine of 50. You can just put that into your calculator. And in this case, there is my angle. My opposite is C, and my hypotenuse is 25. This is my adjacent. Do I need it? Do I want it? No, I don't have to worry about it. So here I've got O and H again. It's sine. I've got my SOH there, so let's just do a big triangle with all of this information. O is at the top. That's C, is what I'm looking for. And 25 is my hypotenuse, so that's over there, and it's going to be sine of 32. So C equals 25 times sine of 32 degrees. And when you put those into your calculator, you'll get 11.5 and 13.2. Hopefully that's reminded you of what we're doing. We are going to be looking at those tomorrow. Please make sure that you have any questions and come ready to be excellent when I see you again. Thank you for listening.